This is William Tomos Edwards from Bright Studies, and today I want to go over my solution to this integral that once appeared on the MIT Integration Bee. The YouTube channel Let's Solve Math Problems already went over their solution. I want to show mine because I think mine's a bit more slick and user-friendly. So let's begin. So first things first, looking at this problem, the first thing I'm going to do is say, okay, we're cubing, the absolute value of x, we're taking a square root. This notation is a problem, okay? This notation that essentially makes it seem as though we have a composite function 3 functions deep, right? It essentially makes it seem as though we have a function of g of h of x, right? That's literally how that seems, and that's bad news. You don't want to deal with that situation. You don't want to deal with 2 functions. You don't want to deal with a composite function underneath a square root. That's bad news. So this problem really gets into something pretty sublime and interesting about mathematics, and that is the notation could have a huge impact on how you solve the problem. Okay, the notation can have a huge impact. For instance, as an aside, we'll often find that dy dx has an advantage over, f prime of x, right? It just simply does, right? For differential equations and things like that. This is a pretty sublime kind of cool thing about math, that the notation counts. The notation counts for problem solving. So first thing we're going to do, we're going to switch that notation up right away. Just switch to that right away. That notation is way better because now we're outside of the realm of tricky, difficult, composite functions. We're outside of that realm and just into the realm of, you're raising x to some power, right? Just a simple power rule. As for the absolute value of x, well, we're going to deal with this the exact same way Let's Solve Math Problems did. You've got minus x on one side of the y-axis and just simply x on the other side of the y-axis. So we go from there and split it up like this, right? Minus x to the power 3 over 2 on one side, x to the power 3 over 2 on the other side. The one goes from -3 to 0. The other goes from 0 to 5, right? The other thing that I go in for here is a u substitution. Let's multiply by the negative there, multiply by a negative out here to maintain equivalence, go in for the u substitution. Great. So let's continue to scroll down and see how that goes. From this point on, now that we've got here, it's just simple plug and chug from here on out. Some of the algebra is surprisingly tricky to get this simplified to the most simplified state possible, but it's pretty much plug and chug from here on out is what it is. And so, you just go through all those steps. You can see how to do it. And we eventually get to hear that the YouTube channel Let's Solve Math Problems got to the same place, right? We simplify it to here. I don't know how pivotal that is, frankly. Simplifying it and all that isn't the hard part. If I was the invigilator for the MIT Integration Bee, as long as you solve it, I don't care if it's simplified. But if you've got to simplify it, sure, that's how you do it. That's all just plug and chug from that point on. But anyways, this would be my style, right? For a recap, that notation sucks. Get it to this notation. I was doing the most simple situation possible. Recognize you got one function to the left of the y-axis, another function to the right. Break up to 2 integrals. The u substitution gives you a much simpler situation. And then you just go through the algebra from there, plug and chug, and get to the answer. Anyways, hope you found this solution. I hope you found it simple and slick. The intention is for it to just be a simple, slick, user-friendly solution.